All right, hey guys. Part of my deal that I'm gonna do for Thursday for the next couple weeks, we're gonna talk like basic, basic EKG stuff. So nothing super in depth, nothing that should blow your mind, but that way when you look at like a 12 lead, you have a basic idea of maybe what you're looking at, and pretty quickly you'll be able to recognize if someone's having a heart attack or not, which is what really matters, right? But to start off for this, we're going to talk real basic anatomy of the heart, and I mean real basic. Like there's 4 chambers and blood moves this way. And then we're also going to talk about the basic electrical system of the heart. So we're going to kind of differentiate between the mechanical and the electrical, and then I'm going to show you on a 12 lead what like a normal heartbeat looks like. And so that's going to be lesson 1 for this Thursday. So that's kind of what the series is about. So your heart anatomy, right? We should all remember this roughly from EMT school. There's your heart, and it has 4 chambers. You have the right atrium and the left atrium, and you have the right ventricle and the left ventricle. The right side is going to be sending blood to the lungs. So it'll send deoxygenated blood to the lungs, and then we're going to have oxygenated blood coming back from the lungs to the left atrium, and then from the left ventricle out to the body. Right, so pretty basic, simple stuff. But that's the mechanical portion of the heart, right? Blood goes in the top, goes down below. Blood goes from the ventricles to the lungs and to the body. So what we care about in the EKG though is the electrical bit of the heart, and that's what we're looking at on the paper. So not necessarily the mechanical portion of it. So I'll just leave that up. Actually, we'll do the electrical right next to it. So there's your heart again, our 4 chambers. So in the top, in the right atrium, there's this guy, this little circle right here, called the SA node. And not really important that you remember the name so much. Just imagine that as like that's the one that tells the heart to beat, right? So it shouts beat to the whole heart, and the heart follows. And there's another guy that sits in between the atria and the ventricles, right in the middle here, and that's called the AV node. So what the SA node does is it says beat, right? And the signal goes out and it hits the atria. And the atria gets the signal to beat, and the top and the bottom both go chunk and squeeze and send blood down, right, into the ventricles. Pretty simple. So what's the issue here? If the SA says beat and the whole heart contracted at the same time, the issue is the bottom of the heart, the ventricles, wouldn't fill with blood. And so you'd still be getting a good amount of blood going to the lungs and to the body, but you're not getting 100%, right? So say it's 80%. So you need to have a delay. The top needs to squeeze, and the bottom, the ventricles, need to stay relaxed so they can fill all the way. And that's the job of the AV node, this guy in the middle. So when the SA node says beat to the whole heart, there's like a wiring system, right? So the SA node is connected to the AV, and there's only one way for that signal to reach the bottom of the heart, and that's through the AV node. And so what the AV node does is when the SA node says beat and the top of the heart listens, the AV node delays that signal just long enough for the blood in the top of the heart to fill the bottom of the heart. And you're going to see this when we write out the actual waveform that you'd see on an EKG. It'll make a lot of sense. But to understand what the waveform is, you have to understand the electrical activity of the heart. And if you don't understand the electrical activity of the heart and how that pathway works, then the EKG makes no sense. If you do, if you understand the electrical pathway of the heart, understanding the bumps and the triangles is super easy. So that's why we're talking about the electrical system here real quick. So again, the SA node tells the whole heart to beat, the atria listens and squeezes. The AV node holds the signal for a very short amount of time, but long enough for that blood to go from the top to the bottom. Then it sends out that signal down what's called the bundle of His, which is just more wires, right here. And then it splits into the right and left bundle branches. So eventually down the road we'll talk about those when there's problems with them. And then it goes down into these little hairs, which are called Purkinje fibers. Not really important that you know the name, but the point is this is the wiring system, right? So it runs from the SA node, it goes down to the AV. The AV node holds it for just a second to let the bottom of the heart fill. Then it sends the signal down the other wires. And the other wires are what tell the ventricles to contract and to squeeze, right? And you can have problems all along these wires, and we have ways of figuring out on the EKG, we can tell which wires are broken and which ones aren't. So let's talk about, so now that we understand that we go SA node to AV node, down the bundle branches, down this other wiring system, then we can talk about like what the waveform actually looks like. And what I mean by the waveform, I'm talking about this guy right here, right? The stuff that you see on like the side of every ambulance, and you see on your EKG paper. So let's break down those bumps that I just put right here. So we're going to take it real slow, one at a time, what they're called and what they represent, and we're going to constantly refer back up here to the electrical system. Because again, this down here, all this right here is just a representation of the electrical system. So let's do it. Okay, so the SA node tells the heart to beat and the atria listen and squeeze. And we see that on the paper as a bump. And we call that first bump the P wave. And so in the P wave, the bump right here represents electrical activity. It represents the atria squeezing, right? This portion right here, where it's just flat, is because there's no electrical activity. Okay, so anytime we see bumps or triangles, that's electrical activity. Anytime there's a flat line, that's no electrical activity. Okay? So that first bump is called the P wave, and that represents the atria squeezing. All right? Then we have this little gap. We have another flat line. And that flat line is the time that the AV node is holding the signal. So that can be long or short, and again, in the weeks coming, like we'll talk about why we see that and like why it's a problem. But for now, know that a normal heart should have a pause, so flat line, a bump, and then another flat line. And that flat line is the AV node holding the signal. So that's a healthy thing. That's good. Then when the AV node sends the signal down the other wiring in the heart and the ventricles squeeze, we get the QRS complex. So that's that big triangle guy that looks like that. And we call that the QRS. And we're going to talk about, again, in future videos, we'll talk about why they call it the QRS. And that can actually look it can look really different depending on what lead you're looking at. But for now, just, a big triangle. That's what we care about. That's the ventricle squeezing. Now, you get another period of like no electrical activity. So we get another flat line. And then you get another bump that looks like that. And we call that the T wave. And the T wave is representing the bottom of the heart relaxing. So it's squeezed. It's squeezed on the QRS complex. And now it's relaxing on the T wave. So the question would be, if the P wave over here, if the P wave is the squeezing of the atria, why don't we see another bump for it relaxing, because obviously if it squeezes, it has to relax, right? We don't see it because it's happening during the QRS. It's happening so when the ventricles squeeze, the atria are relaxing, but the ventricles are so much bigger, we don't see a bump for the atria relaxing because, again, the signal from the ventricles is so much more powerful. So you won't see, even though 4 things are happening, atria squeeze, atria relax, ventricles squeeze, ventricles relax, we only get 3 bumps on our piece of paper. We don't get 4. So that right there, what I have drawn right here, that is like a normal heartbeat. So that's what my heart and your heart looks like if we were to take an EKG right now. We have a P wave, a little gap of time, a QRS complex, which is your ventricles squeezing, another gap of time, T wave, which is your ventricles relaxing, and then that would just repeat on and on and on and on for as long as we repeat the paper. And so this is what we're looking for. So if someone's, saying, oh, I got chest pain or whatever their issue is, and I print out a 12 lead and I see P, QRS, T, and it looks just like what I drew here, then, the chances are that there's not something wrong with their heart today. What's going to be really cool, and what we'll talk about going down in the next week or so, is when there's a problem with the heart. And you're going to see that the changes are subtle, but they're pretty easy to recognize. And I'll make you this promise, like when we talk about heart attacks, by the end of that video, you're going to be able to recognize a heart attack really easily. This is not, like you've heard me say a million times, like this is not hard stuff, right? It's just a lot of it. And so for the 12 lead stuff, we're just going to keep it super basic. And if you're interested and people like it, then we'll get more in depth. But for now, we'll just do a quick recap here, right? So we have the mechanical over here, and we have the electrical over here. And so what we really care about is this. We really care about the electrical system of the heart, because that's what we're seeing in the 12 lead. So yeah, hopefully this is like a super basic, easy intro. If you guys have any questions, like obviously post down below. It's the whole point of this. We'll talk about it. Hopefully you guys have questions that I don't want to answer yet, so we can get to those in the next video. But yeah, if this kind of stuff was useful, of having the video and being able to draw, if that was good, let us know so we can like keep doing stuff like this. Yeah, thanks guys.